Hello guys, what's up? How are you everyone? How are you Zimbabwe? How are you Africa? How are you UK, Australia, India, China, and many countries? And I'm happy the learning is taking place, and I can't believe how people are supporting a black guy from Africa. So let's learn something today. We do have some kind of job which is now becoming common, especially on developing countries who are still using solar system. People, they are using inverter. We have this inverter. That's the inverter. 12 volts DC to 220 AC inverter. These kind of inverters, they are being used on rural setup. Nowadays in developing countries, especially in my country, even in town, they are now using solar system because we are facing challenges with electricity. The rate of load shedding is too high, to the extent that people, they are now switching from using electricity to solar power. Okay, so this inverter was booked in as no power, but we need to understand what kind of faults we can get on such kind of inverters. Okay, because many people, they are fixing things, but there are very few people with electronic knowledge who really know what's really going on there. That's why this inverter is already opened, because this is coming from another electronic shop. They opened, they couldn't figure it out what is the problem, and luckily I was checking, they didn't do anything inside, and they sent the inverter here. So before fixing this, let's just do a little bit of theory. Okay, let's put this, before we diagnose, let's put this inverter aside and do a little bit of theory. Okay, I think that's very important to understand how inverters are working. That's good. I think I have some plain paper here. So perfect. So on inverter, I'm talking of this cheap inverter, not hybrid inverters, these cheap ones. Okay, so I'll draw how I see the schematics on these small inverters. Okay, here we have 12 volts DC input, that's the plus, and here we have minus, and where our 12 volts is going, we don't have many things here. We have like the IC chip, that the IC chip or the driver. The plus is going straight to the driver. That's the driver. And it's got many pins, but that's not important. So after the driver, what do we have here? We have like two MOSFETs. That's the first MOSFET, that's the second MOSFET, and these are some kind of n-channel MOSFET. N-channel MOSFETs can be like I found a different version of n-channel MOSFET, like for example IR FZ44 MOSFET. So what is inside this MOSFET? Here we have the gate which is going to the chip. That's the gate which is going like two gates. And what do we have? We have, that's our gate here, our gate here, and here we have like, here what do we have? We have source and the drain. That's the drain. Source is going to ground, and the drain, I will show you where the drain is going. And here what do we have? We have same configuration. That's our MOSFET. We have a source which is connected to ground, and our gate, our drain source. So that's our drain. So on MOSFET we have gate, drain and source, and on transistor we have a base collector emitter. That's clear, okay? So after this, is going straight to the primary stage of the transformer. That's the transformer. And we have secondary. On the secondary, what do we have on the secondary? We have nothing, because this is like a linear transformer. It's a big transformer. On the secondary we have AC 220 volts AC. That's what we found here on the output. What this transformer is doing is boosting voltage. In that way we have high voltage on the output, because the 12 volts is coming here to this chip, and inside this chip we have like bridge rectifier inside this chip, which is changing from DC to AC. And the AC will be lower voltage, and these switches, they are switching up and down, up down, like more than 40k per second. In that way we have voltage on the drain here, which will come to the primary stage of the transformer, and the transformer will then boost the voltage to the secondary. Okay, that's the primary stage, and that's the secondary stage. So basically that's how these chip inverters they are working. I'm not talking of hybrid inverters, I'm talking of these chip symbol inverters. Okay, so between the chip and the MOSFET is connected to the chip by the gate. And here what do we find here? We find like let's say 100 ohms resistor here along the way. We find like 100 ohms resistor here, which is connected to gate, going straight to the chip. Okay, so basically that's a simple schematics for these chip inverters. So my next question is, what can be fault here? I'll show you three things that we have to check on this kind of inverters. Number one, this is number one, the driver itself. Yeah, this driver can be faulty. I found the IC, the controller of the inverter itself shorted, or these two MOSFETs, you see, these two MOSFETs can be shorted to ground. And the third thing that can be fault on this is the transformer itself. So either we have a shorted driver or shorted MOSFETs, or the transformer itself can be shorted. So let's go back to our problem and see what exactly is our problem. Okay, good. So we have the, like what I said, we have these two wires. These are the wires, plus and minus. You can see plus and minus, which are going straight here, straight to this panel. Maybe you can't see the panel. Let me take down the panel. Let me take down this panel. That's the panel here. We have the panel, and here you see this long chip. That's the driver which we talked about, and here we have like two MOSFETs. These are channel N MOSFETs, and we do have these resistors which I explained. You can't see them because they are smaller here. And after that, on the output is going straight. You see these wires, they are going straight to the primary stage of the transformer. And on the secondary, we have these wires which are going straight to the output. So what I will check? I will check straight, because here we have the panel. We have two wires which are coming from the plus and minus. I'll check. I'll put my multimeter on diode mode, and we'll check plus and minus. You see, plus and minus, we have a short. Even if I go to the wires here, that's the minus and plus, you see. So we have a short here on the input, on the 12 volts input DC section. We have a short here. So let's check few things here. Of course, we are not working with the schematics, so I don't know the pinout configuration for this chip, but I'll stick one probe on the minus, and I'll go straight on the chip. Okay, on the chip you can't see anything because we don't have schematics. Let's skip the chip. In our next move, let's check these two MOSFETs. The first one, gate, drain and source. The second one, gate to drain on the second one is shorted, and on the first one all pins they are like 0 0, gate, source and drain. So now you think all these MOSFETs they are short. The second one, the gate and drain is shorted because we have a shorted first MOSFET. So this one with all 3 pins which are shorted, I believe that is my problem. But let's take down that MOSFET quickly. This one, let's take it down. As easy as that. So what I will do, that the MOSFET, I'll stick it here. Let's check this MOSFET off the circuit. So this MOSFET is shorted. Let's go back to the second MOSFET and check again. You see now? It's not shorted. It's not short. There's no more short anymore. And if I'm to check on this, on these wires, plus and minus, it's not like 0 0 before. So that is our problem. Okay. So let's look for another MOSFET and replace this MOSFET. This is a channel N MOSFET. We can replace even with the TV boards. We do have so many MOSFETs here. Let's just take any. From this is a TV board panel. Let's take any, because all they are doing all these are power MOSFETs. So there's nothing special here. So let's take down that MOSFET. We are replacing with the N MOSFETs. I'm just taking a random MOSFET doing same thing from a TV board. That's our new MOSFET. Let's see whether we can bring this inverter to life or not. Inverters, they are easy to fix. Nothing complicated here. Nothing complicated at all. Nothing complicated at all. So we now have our MOSFET. So what is left is to put the MOSFET in position. That's the new MOSFET which I took from a TV board. I'll solder all these 3 pins, gate, source and drain. So we are done. Let's test for short. We didn't test this MOSFET. Hopefully it's a good MOSFET. Gate, drain, source. Oh, looks good. So let's put back everything. I need my screwdriver. Let's put back everything, then we can test together whether our problem is solved or not. So that's the thing about inverters. That's the thing. We have a broken wire here. Let's resolder back this wire, which is going to the LED. After that, we can test the inverter. That's all. So I don't think we have too many faults here. Let's set the multimeter on DC power supply on 12 volts, 12.11. What about current? Let's lower the current to 2 amps. That should be okay. 2 amps. Now the white, that's the minus, we shall stick here, and the plus. You can see the fan spinning. The fan is spinning. I can't believe. We have the fan is spinning. And it's taking around the 600 milliamps, which is fine. Let's see what we have on the output here. You can see the fan is spinning. Let's go straight on the output AC. What do we have here? Let's check now. What am I doing wrong here? We have like 70. It's not meant to work with 70. Why do we have 70 on the output? That's not a good sign. Okay. So we have a problem here. We have a big problem. Why the transformer is outputting only 70? Let's take down that MOSFET which we replace. Let's take it down. This one. Let's take this MOSFET down. Let's take down this MOSFET. I want to see something. Our MOSFET is out. Let's try to test with this one. Let's see what we have with one MOSFET. One level. So let me look for a proper MOSFET. Okay, let's see now what we did. Just to recapture, that was the original MOSFET from the board. This one. Which is a reading like short gate source to drain. All the pins, they are shorted here, and I replaced with this MOSFET which I took from the TV board, and the MOSFET didn't work. But this is an N channel. I think the rate of switching was different, so I found another MOSFET which I took from another inverter board from the board for space, and I think we can test. Do you think that will gonna work? Let's see now. What do we have? Stretch. I can hear the transformer AC. Let's see what we have. 244 volts. You see, it's working. Fan is spinning as full beat, and we now have output. Okay, so even here it's working. So you see, 244 volts AC. So those are the three major areas we have to look if we have a non-working inverter. First, check on the driver itself can be faulty, the MOSFETs can be faulty, and also this big transformer. You see this? You can have a faulty transformer. This is a linear transformer. Okay, so like, subscribe, don't forget to turn on the notification bell. See you on the next game. Okay, bye.